Working through the review packet for 5.4 through 5.10, skipping over section 5.7. So we are starting in 5.4, all about conversions, multiplying by some conversion rates to get things from, say, miles per hour to kilometers per hour, or all different units. So there are different ways to go about this, but the way we specifically were studying these is we would set up a rate and then multiply by the conversion rate. So for number 1, we have 70 miles per hour, so 1 hour. We want to turn this into kilometers per hour. So we're good with the hours, we just need miles to become kilometers. So we only need one conversion here, and we're going to go from miles, which I'm going to put to the bottom so that they cancel. We need it to become kilometers. And in the end, it needs to be kilometers per hour. So once these miles cancel out, we've got miles per hour. So we are all set there. Our final answer will be in kilometers per hour. Now I need to drop the numbers in now that I've set this up correctly so that the miles cancel out, leaving me kilometers. So this second conversion rate comes from right here. 1 mile is 1.61 kilometers. Across the bottom, we're just going to get 1, so we really just need the top here. So we are multiplying 70 times 1.61. And it's 112.7 kilometers per hour. Number 2. Scale measures an infant that weighs 3.6 kilograms. How many pounds does this infant weigh? So we're going just from kilograms to pounds. So we're not even given a rate. This isn't kilograms per hour or something along those lines. It's just kilograms. So 3.6 kilograms. And since it's not per anything, I'm going to put it over 1 just so that I can see it as a fraction when I multiply by the conversion rate. It's 0.45 kilograms for every 1 pound. Here's kilograms. You want to put it on the bottom so they cancel, leaving you pounds. Now, if I cancel these out, I'm left with just pounds, not pounds per something, just pounds, which is what I want. How many pounds does this infant weigh? And so I can drop the 0.45 with the kilograms, the 1 with the pound, straight from this conversion rate right here, multiplying straight across. So I'm going to get 3.6 over 0.45. So when it doesn't end up over 1, I'm going to go ahead and divide these numbers. So 3.6 divided by 0.45 comes out to 8. And again, the only thing left over is pounds. So my answer is not a rate, it's just 8 pounds. Number 3. Gary gets this fish. He's 8 centimeters long. In a few months, it will have grown 3 inches. So we've been given something in centimeters, and the new growth is in inches. How many centimeters long is the fish after a few months? So here's the big mistake everybody makes. They want to start writing this out with the 8. And so this is one of those instances where they've given you more information that you need, or at least given you information that you shouldn't be doing anything with until maybe later on in the problem. We are going to need the 8 to figure out how long this fish is now. But in terms of conversions, they want the answer in centimeters. This is already in centimeters. So we need to convert 3 inches into centimeters so we know how much it's grown in centimeters, and then add it to the original 8 that it already was, and that's going to give us our total. So what I'm actually converting is 3 inches. Now again, it's not 3 inches per hour or anything like that, so it's just over 1, and I'm going to times this by my conversion rate. Inches on the bottom, so they cancel. So centimeters is on top. 2.5 centimeters for every 1 inch. You can see it's all 1s across the bottom. So really I'm just multiplying 3 times 2.54. I get 7.62 centimeters. Now again, that's what 3 inches is in centimeters. So that's how much it's grown in a few months. It's grown 7.62 centimeters. So it started at 8, it's grown 7.62. You got to put those together for a final answer of 15.62 centimeters. Okay, number 8. This car can travel at 35 miles per gallon on each gallon, 1 gallon. How many kilometers can it travel on a liter? So miles has to become kilometers. That's one conversion. And gallons need to become liters. That's a second conversion. Now, I feel like some students are getting hung up on the numbers and where do they go. What we really need to be thinking about is where do the miles and kilometers fit? Where does the gallons and liters fit? So we're looking for things to cancel. Here's miles, so I need miles to go on the bottom, meaning kilograms goes on top. What that does is cancel, and if I left it just like this, I'd find out kilometers per gallon. And I don't want gallons though, I want liters, so I have to come up with another conversion rate right here. I put gallons up top so that they will cancel. Liters is going to go on the bottom, so my gallons cancel. And now once I drop the numbers in and multiply, the units that I'm left with after the miles cancel and gallons cancel is kilometers per liter, which is what the question is asking for. So now I can drop the numbers in the right spot. So my first conversion from miles to kilometers, it's 1 mile equals 1.61 kilometers. And my gallons to liters, 1 gallon is 3.79 liters. This is one where I'm going to get a number on the top and the bottom. So I'm going to multiply straight across. So 35 times 1.61 is 56.35. And then on the bottom, I'm going to get 3.79. We'll go ahead and divide that. And we'll round this off. It's not going to come out to a perfect number. So we're going to go 14.87. Now again, they don't tell you exactly how to round in the question, so you can round it however you feel fit, but it's kilometers per liter. Okay, number 9. This is one where they did not give you a conversion from meters to kilometers. So if you didn't know what it was, 1 kilometer equals 1,000 meters. So we're going to go ahead and use that conversion rate to change this into kilometers per hour. Now this is meters to minutes. So meters needs to become kilometers and minutes needs to become hours. So you can do this in 2 conversions, but I see a nice easy way to get this into hours. First of all, I could set this up as 0.5 hours. That's fine because 30 minutes is half an hour. Or I could double the 30 minutes and double the meters, and that would tell me how much in 1 hour. And then all I got to do is change the meters to kilometers. So either way is fine. Let's go ahead and do that. Let's double this. So for 60 minutes, I'm going to take 3219 and I'm going to double it. That's 6438. So 6438, that's meters. And now that's in 60 minutes, so 1 hour. So I have meters per hour, but I want kilometers per hour. So all I need to do is change meters to kilometers. So I'm going to put meters down here and kilometers up here so that meters cancel out. And now I have kilometers per hour. Dropping in my numbers now, 1 kilometer is 1,000 meters. So I'm just going to go ahead and divide. So 6,438 divided by 1,000. Since this is a power of 10, it's just sliding that decimal over by the number of zeros, 3 spots. It's 6.438 kilometers per hour. Okay, number 10. 2 inches of rain fell in 15 minutes. So 2 inches, 15 minutes. They want us to convert this to feet in an hour. So inches needs to go to feet. I'm going to put inches down here so they cancel, feet up top. Minutes needs to become hours, so minutes up top, hours on the bottom. Minutes cancel, inches cancel. Check your units, feet per hour. That's what we want. So now go ahead and drop in the right numbers. If you're comparing feet and inches, there's 12 inches in 1 foot. Comparing minutes to hours, there's 60 minutes in 1 hour. Now I can multiply straight across. So 120 on top. 15 times 12 is 180 on the bottom. I can divide these by 10. I'm going to have 12 over 18. If I go ahead and divide that, 12 by 18 or even 120 by 180, I get 0.6 repeated. We need to know that's 2/3. And if you had divided these by 6, you would have got the 2/3. So my final answer is 2/3, and this is feet per hour. I'd prefer to not get the 0.6 repeated. 2/3 is a better answer. All right, 11. They throw some numbers at you. This is another one that you don't necessarily use all of them at once. So he purchases 8 yards of rope for 2 swings. So be careful. It's not 8 yards per swing. He's already purchased all 8 yards. It's for both swings. So it's actually 4 yards per swing. This number here is irrelevant. It doesn't affect what's going on here. They're asking us what the rope costs. Okay, so it doesn't matter how many swings you're going to make. Okay, right now, what's the cost of rope per swing? So what we have to find is how much it's going to cost altogether, and then at the very end, we can go ahead and split that into 2 so that we know how much it is per swing. So he purchased 8 yards altogether. The first thing we have to do is figure out what's the total cost. Forget the fact that there's 2 swings. It doesn't matter how many swings. That's not affecting our total cost. What's affecting our total cost is the fact that there's 8 yards of rope. So rope is 40 cents per foot. So first of all, we need to translate yards into feet. So we have 8 yards. You could go ahead and say, 2 swings, but it's honestly making things more complicated. All we need to do is figure out 8 yards is how many feet, and then we can translate that into the cost per foot. So this I'm going to put over 1, and my conversion I'm going to put yards on the bottom, and I'm going to put feet on the top. So there is 3 feet in 1 yard. So yards are going to cancel. This is 24 feet. So if he's purchasing 8 yards of rope, that's 24 feet. It's 40 cents per foot, so I'm going to go ahead and multiply it. 24 times 0.4 comes out to $9.60. So that's the total amount of money that's being spent. Now we can answer the question, what's the total cost of rope per swing? So we're going to go ahead and divide this by 2 because this is for 2 swings. So divide that by 2, and your final answer is $4.80 per swing. Now we could have put this into the conversion. You could have said 8 yards for 2 swings, and then we could have converted it along the way. Nothing wrong with that. But for this one, since going from yards to feet is quick and easy, I think it's just a little bit easier to go this way. But if you were able to go through a whole conversion with 2 swings down here and getting it down to just per swing, perfectly fine. Okay, so 5.5. The chemistry set originally cost $140. It's on sale for $125. Find the discount rate. Discount rate is as a percentage. So we're going to compare the amount that you saved, which is the discount, to the original cost. We're always comparing to the original cost. So 2 ways to do it. I'll show you both ways. We're always comparing to 140. Some people would go ahead and divide by 125. The better way, we're trying to find the discount rate. So you want to put the discount compared to the total. The discount is how much you actually saved, how much came off the price, which is $15. And so you could compare 15 to 140. So let's start there. If I go ahead and divide 15 by 140, I get this. It's a percent. You move it 2 spots. So 10.7%, which you could have rounded up to 11%. And if I did 125 divided by 140, I get 89.2 or 89.3. What that's telling you is the new price is 89.3% of the old price. So what came off was this. If you subtract this off of 100, you do 100 minus 10.7%. Now you get the 89.3%. So the new price is 89.3% of the old price, which means the discount was 10.7% or about 11% is what it said on the book's answer key. Number 2, salad is made of 4 parts olive oil, 3 parts lemon juice, 1 part vinegar. How many ounces of each is needed to make 3 cups, which is 24 ounces? So we're going to ignore the 3 cups and just do this in ounces. So we have 4 parts plus 3 parts plus 1 part total to make 24. So if I combine all of that, that's 8p. 4 and 3 is 7 plus the 1. is 8. So you're going to go ahead and divide by 8, and you're going to get P equals 3. So each part is worth 3. So the one part, vinegar, is 3. So 3 ounces of vinegar. Now the other parts, we had 3 parts lemon juice. Each part is worth 3. So we're going to go ahead and multiply. So that is 9 ounces of lemon. And the olive oil is 4 parts. Each part worth 3. So multiply it, and that's 12 ounces of olive oil. Number 6, same idea. They want a specific shade of orange that you have to have a ratio of 7 to 4 with your red to yellow. It's going to use 12 gallons of paint. Oh no, he says 12 gallons of yellow paint. So we got to go about this a little bit differently. So we're not adding these to a total of 12 because the 12 gallons doesn't represent the total gallons we're using. The 12 gallons is just the yellow paint. So that's the 4 parts. So 4 parts equals 12 on its own, not adding the 7 in. So we're going to go ahead and divide by 4 here, which means each part is worth 3. And if you want to find the total now, you have 7 parts red plus 4 parts yellow. And so we're going to go ahead and drop that number in now. Each part is worth 3. So it's 21 plus 12. This gives us a total now of 33 gallons. So we're on this one. They gave you the total number of ounces in this case, and it was split up into all these parts. Here they gave us the 2 parts, but they told us the 12 gallons is not the total. It's just the yellow paint. So we only set the 4 parts yellow equal to 12. That means each part is 3, and then we went back and applied it to both the red and the yellow to find out the total number of gallons. All right, number 7. The staff at a high school newspaper consists of all these different ones, 7, 9, 9, and 1. What's the ratio? So ratio is just a fraction, or it can be written with this, 1 to 2 or 1 to 2. That's a ratio. That's all they're asking for here. So you don't have to solve for anything extra. Just set up the ratio of sophomores to total staff. So this to this, sophomores to total staff. So sophomores is 9, and total staff, add them all up. 7 and 9 is 16, plus 9 is 25, plus the 1 is 26. So the ratio is 9 to 26. You would simplify if you could, but 9 over 26 is fully simplified, and we're going to leave it just like that. Number 8. Camera at the airport where it's duty-free, which means there's no sales tax, is $150. So people always think they're getting deals because they're like, hey, there's no tax. I'm going to go ahead and buy it here. It's cheaper. But in the city store, it's $135. Now you have to pay tax on it, 6.25%. But which one's actually cheaper? So the first one just cost $150 flat, no tax, nothing extra. This one's $135 plus a 6.25% tax. So what we want to do is we want to go find out how much is this going to cost with the tax. So 2 ways to go about it. You can go ahead and find the tax, which would be 135 times the percent. Move it 2 to the left, 0.0625. That'll give you the tax. Or if you want to know how much it's going to cost with the tax in it, that's going to be 106.25%, which is 1.0625. So if we go ahead and run these across, this one you can see is going to come out to $8, and if you round up 44 cents on the tax, which you'd have to add on to the 135 to get the total cost. Or here, if we go ahead and multiply 135 times 1.0625, it just gives us the answer right away. We don't have to add it in. So it's $143.44. So go answer the question, which camera is actually cheaper? And it's going to be the one in the city store. Even though there's tax on it, after taxes, it's $143, where the other one was $150. Okay, so 5-6, looking at probability. The event of a probability is T. What's the probability of its complement? So they're really just testing, do you know what complement means? So complement is when you have 2 different possibilities and it covers all the probabilities, like flipping a coin. Heads and tails are complements because they cover all of the possible probabilities. If you have a 1 to 4 possibility of something, and there's a 3 to 4 possibility of everything else. Those are complements. Notice that they add up to 4 over 4, so 1 whole. Probability of heads is 1 out of 2. Probability of tails is 1 out of 2. All together, it's 1. So that's the mathematical definition of a complement, is the two probabilities are going to add up to a whole number 1. So that's what we're going to use to go ahead and find the expression that represents this. So if this event has a probability of t, which is just a variable, what's the probability of its complement? So let's say we all of a sudden found out what the probability was. Let's say it was 2 out of 5. You would have to subtract that away from 1 and see what you're left with, which would be 3 out of 5, to go ahead and find out what the complement is. So we're going to take whatever t is away from 1. So when we express that, it's just 1 minus t. So t plus its complement is going to equal 1. So if I want to find the complement given t, I have to do 1 minus t. Normal deck of cards for these next two questions. What's the probability of getting a king or a queen? So this is what's the probability of a king or a queen. 4 kings, 4 queens. So that is 8 out of 52. That does simplify. You can plug it in your calculator or just go ahead and divide it by 4, and you're going to end up with 2 over 13. What are the odds that the card is not the ace of spades? Now, they asked what the odds are, and I did notice that the answer key gave you probability. So the probability that the card is not the ace of spades, how many cards are not the ace of spades? 51 out of 52. That's the probability. The odds, though, is how many are compared to how many aren't. So the actual correct answer is 51 to 1. There is 51 cards that are not the ace of spades compared to 1 that is. So the odds are 51 to 1. The probability is 51 out of 52. Number 4, they give you 3 different events. Can any 2 of these events be complements to one another? So to be complements, going back to here, they have to add up to 1 whole, or 100%. And 30%, which is 0.3, 30% and 40% does not give you 100%. 1/3, remember we should know 1/3, but 1/3 is 33%, 0.3 repeated. So if I had 33% and 40, or 33% and 30, or any of these 3, am I ever going to get 100%? So the answer is no. So complements will add up to 100%. They're the 2 possibilities in a given situation. So in this case, none of these can be added up to 100%, so they are not complements. Number 10, 15 boys total, 12 of whom are over 5 foot, which means 3 are less. 16 girls, 10 of whom are over, that means 6 are less. In this class, what's the relative frequency of students who are 5'5" or under? So under would be this group right here. So the probability is 9, 3 boys, 6 girls, out of, and the total number of students, 15 and 16, is 31. So 9 out of 31 are less than 5'5", and that does not simplify. This is done. So 5'8", we're continuing with probability. So we're looking at the chances of something happening compared to the total number of possibilities. It always goes back to that. But now we're looking at more visual things. And so we're always going to be looking at, say, a target or a piece of a line, and you're going to compare it to the total. By comparing, I mean set it up as a ratio, and then because we're going to look at probability, we're going to divide and make it a percent. So number 1, you've got this 100 by 40 area. Okay, and in here they're telling you that this represents a dog on a chain. So it's chained up here, and it can go all the way 12 in any direction. So it's a circle that it can make with a 12-foot radius. And softballs hit into the yard. What's the probability it lands in here? So even if you didn't read the whole thing, just looking at the picture, what's the probability that it lands in here? So anytime we're looking at this type of problem, we're comparing the area that it could have fallen in here compared to the area of the whole thing. So we're going to set them up as a fraction. We want to know what percentage does this circle take up of the whole thing. So first thing we have to do is find the area of the circle, excuse me, which is pi r squared. So 12 squared, which is 144. And you can't forget to leave pi in there. And if we're looking at the rectangle, it's base times height. And so that's 100 times 40. And it doesn't matter which way you write that. If you decided that 40 was the base and 100 is the height, it doesn't matter, because when you're going to multiply, you're going to get 4,000. And so to set this up now, the probability is the area of the circle compared to the full area. So we're looking at our favorable outcome, the chances of going in this circle. Okay, you've got 144 pi square feet compared to the whole thing, which is 4,000 square feet. We're going to go ahead and divide. Now, if you notice, this is not a circle clearly, so there shouldn't be a pi. Don't throw a pi in there and then cancel it. This pi will not cancel. It is part of this equation. And so when I go ahead and set this up, I need to include the pi in my math. It doesn't go away. So 144 pi, which remember is 144 times 3.14, so times something. So it's not 144, it's a bigger number. That whole thing is going to be divided by 4,000. And this is the percent. It takes up about 11%, so there's an 11% chance. About 11% chance of it going in here. Okay, number 2, they give you this parade route. There's a portion between A and B that's in view of the reviewing stand. He's worried about tripping. Okay, if he trips at a random point anywhere on this, what's the probability that is inside of the president? So what's the chance that it's in between A and B is what they're asking. So we're comparing this distance, which is 0.5, to the entire distance that they're walking. And if you add this up, it's 4.5. And so we're going to do 0.5 divided by 4.5, we get this. You slide it over, it's about 11%. Number 3, a spinner is spun. What's the probability that it lands in region A? So we need to figure out how much this is taking up of the total. A full circle is 360, so this is going to be out of 360. The total possibilities is covered by 360 degrees. What we need to figure out is how many degrees are in here. So we're going to add up 150 plus 90 plus 60, that's 300. Okay, when I add all of those up, it's 300. So all of this is 300, which means if the whole thing's 360, this must be 60 degrees. So you put 60 over 360. Now just looking at that, I can see the zeros drop off, and 6 out of 36, divide those by 6, and I end up with a 1 out of 6. But we're going for percentages here anyway. So the 60 divided by 360 is 16%, 16.6 rounding to 16.7. So again, I'm not testing your rounding here, so 16.7%, something along those lines. If you round it up to 17%, that's perfectly fine. And number 5. You've got different circles in this target. Okay, and they give you the radius of each one. Arrow is fired randomly. What's the probability it lands in region B, which is the shaded region? So first of all, when we compare this to the total is the area of the full circle. Anywhere inside this big circle, including the shaded, including the little circle, including out here. So we need to find the area of the big circle. Well, that's pi r squared for the big circle. Radius is 35. So again, pi r squared. You're plugging in 35, and you're squaring it. 35 squared comes out to 1225. So our total number of outcomes here, the total area is 1225 pi. Now the tricky part is finding out the area of just the shaded region. So if we go ahead and find the area of the circle that has the radius of 25, 25 times 25 is 625. That would include the inside here. So if I go ahead and just find the area with the radius of 25, that's everything inside of here. So that includes the little one. Now we just want the shaded region, so we have to cut out the little one. So we now need to go find what's the area of the little one, take it away from this, cut it out, and then we'll be left with the shaded region. So 15 squared is 225 pi. And so The full inner circle, medium-sized circle is 625 pi. The little circle is 225 pi. So if I cut that out or subtract it, 625 minus 225, that's going to leave me with 400 pi. So this right here is 400 pi. So the chances of hitting that area compared to the full area, now I do have a pi on the top and the bottom, so those cancel. If you don't cancel them, that's fine. You can just punch them into the calculator along with the 400 and the 1225. It'll work out. And we're going to slide that over 2 spots, about 32.7%. Okay, so for 5-9, we're going to practice some cross multiplying and then setting up some word problems that involve cross multiplying and proportions. So when we have these ratios equal to each other, property says that we can multiply the means and the extremes. So right across is 9x. They should be equal to each other. If the two ratios are equal, then the product of the means and the extremes is also equal. So 9x equals the product of 8 times negative 144, which is negative 1152. And now you just solve that equation. So divide by 9. And we get negative 128. So here, 2 times 81 is 162. 3y times 6 is 18y. Divide by 18. And y equals 9. Now here, we're multiplying 11 times a, that's 11a, and 10 times all of this. So if you were going to write it out without actually doing the work quite yet, it's 10 times all of this in parentheses, so you will need to distribute, so it becomes 10a minus 50. Now you can go straight to that step. You can do 10 times a is 10a, and 10 times negative 5 is negative 50, and skip this middle step, that's fine. Now I have a on both sides. I want to get rid of the smaller of the two, so it goes away. So I have a equals negative 50, and that's my final answer. Okay, so number 4, 7 times c, and then 12 times all of this. So I need 12 times 19, 228, minus 12 times c. I'm going to get rid of this, so it comes on this side. I don't want to get rid of the 7c. 1 is bigger than negative 12 anyway, but I don't want to clear out this whole side. So this is the c that I want to get rid of. I'm going to add 12c to get rid of it since it was negative. So I have 228 and 19c. So 228 divided by 19, c equals 12. Across here, I get 20d from the 4 times the 5, and then I'm going to get 8d, 8 times d, and 8 times 1 plus 8. D on both sides, let's get rid of this one. So I'm going to have 12d equals 8. I'm going to divide by 12. If I do 8 divided by 12, I don't get a nice number. It's 0.6 repeated, which we need to know is 2/3. So you could have just simplified the 8 over the 12. So d equals 2/3. Right here, 4 times 2, that's 8e. 9 times e is 9e. 9 times negative 7 is negative 63. Now the smaller of the two e's here is the 8, but I don't want to clear out that side, so I'm going to go ahead and minus 9e. So because I've done that, now I have a negative e equals negative 63. I do need to divide by negative 1 to get rid of it. So that clears out the negatives on both sides, so e equals positive 63. Number 7, 2 times all of this, I'm going to get 2f plus 12. 3 times all of this, that's 12f minus 3. Now it doesn't really matter which one, so I'm going to go ahead and get rid of the smaller of the two. So I'm going to go ahead and minus 2f from both sides, leaving me 12. And I'm going to get 10f over here. minus 3. So I'm going to add 3 to clear this out. 15 equals 10f. Divide by 10. And when you do 15 divided by 10, that's going to be 1.5. So in number 8, we are multiplying across both ways. So we've got 8 times g minus 9, 2 times 5g minus 2. Distribute. And we're going to get negative 72, 10g, 2 times 2, negative 4. G's on both sides. So we will eliminate the smaller, which is the 8. Bring down the minus as a negative. 2g minus 4. Now we're trying to get g by itself, so add 4 to both sides. So negative 68 and divide by 2, and our final answer is negative 34. Last one, 5 times 7, 35h. 15 times both of these, so we're going to get 30h plus 15. H on both sides, but we don't want to eliminate this one, so we're doing this one no matter what. So 5h equals 15, divide by 5, and h equals 3. Okay, so some good quick practice on cross multiplying. So down at the bottom now we're going to set up these proportions, 2 equal ratios, so that we can cross multiply and solve. So 19, these two guys have autographed baseballs. Pierce has 3 more than twice the number of baseballs he has. So first let's translate that into an algebraic expression. He has 3 more than, so we're adding 3 to, 3 more than, twice the number. That would be 2x. So the one guy has x, the other one has 3 more than twice the number. The ratio of the number of baseballs that Fabian has collected to the number that Pierce has is 3 to 7. So we're going to go ahead and set up that initial ratio of 3 to 7. And we're going to go ahead and set up these two terms, or these two expressions, I should say, on this side of the proportion for this ratio. And clearly the x is the smaller, as this is the bigger one, times 2 plus 3. So we want to line these up. We want to put the x up here, 2x plus 3 down here. And now all we have to do is cross multiply. So we're going to get 7x. 3 times all of this is 6x plus 9 minus 6x, leaving you just x equals 9. So x is 9. To answer the question now, how many autographed baseballs does each have? Okay, so if you look at this, it's basically like a 3x equals 9, because that's the smaller one. So we have to find out what 7x is going to equal. Now, x would equal 3 in this case. And so 7 times 3 is going to be 21. So we have 9 for Fabian. And we have 21 for Pierce. If this didn't make sense here, the other thing you could do is go back and set up a new proportion. We know the ratio is 3 to 7, and now we know that the smaller of the two, the x, is 9. And you could solve for this. I'm going to call it y just because we've used x all this time. And if you cross multiplied, you'd get 63 equals 3y, divide by 3, and y equals 21. Or you go back and you plug the 9 into just both spots right here. And you're going to get 9 here, and then you're going to do 9 times 2 is 18 plus 3 is 21. So I just gave you 3 different strategies for coming up with the 9 and the 21. So question 20. There's a capture-recapture program checking the number of fish in this lake. So 1 year there's 50 that were tagged. 2 years later, 20 were netted, which were caught. And out of those 20, 2 were tagged. So 2 tagged out of 20 total. So that doesn't mean there was 20 in the lake altogether, but out of the 20 that they caught, 2 were tagged. So we're going to go ahead and estimate the total number of largemouth bass that are in Long Lake. We know that 50 were tagged. So we're going to compare this to the bigger version now of the whole lake. So if there were 50 tagged, And they were in the same ratio as the ones that they caught, which is not the best experiment ever because there's lots of different factors that could have came in here. But comparing, out of every 20 you catch, 2 are tagged, then we're going to just expand that out. If there are 50 tagged total in the lake, what's the total number of fish in the lake? So we're going to go ahead and cross multiply. 50 times 200 is 1,000, and that's going to equal 2x. So we're going to divide by 2. So at that rate of 2 out of 20, that means if 50 were tagged, there is about 500 in the lake. So on to 510. Number 1, artist used 1.5 black chalk, so 1.5, to draw a self-portrait. He then made a larger portrait that was exactly the same as the first one and everything but the size. So it's just an enlargement, and he used 4 for the larger one. What is the ratio of similitude between the two drawings? So the ratio is just setting these up as a comparison. So it's 1.5 to 4. Now, ideally, we don't put decimals inside of fractions. So to get rid of this decimal, we're going to multiply by 10. So if we times this by 10, it moves the decimal over. So 1.5 becomes 15. 4 times the 10 is 40. These ratios are equal. If you divide 1.5 by 4 and 15 by 40, you will get the same decimal answer. So the ratio is 15 to 40 using an equivalent ratio but without decimals. And we're going to go ahead and simplify this all the way. You can plug it in your calculator, but dividing by 5 leaves us 3 over 8. So the ratio is 3 to 8. Okay, number 2. Student has a replica that is 1.5 feet tall. On a trip, he puts it next to the actual monument. The replica casts a shadow that was 1 foot long, so the shadow is 1. The Washington Monument's height, we know, is about 555.5, so 0.5 feet tall. And they want to know how long is the shadow, so that's x. So we're going to go ahead and set up a quick little proportion. So starting, you always want to include your x. So you can do 1 over x or x over 1. Just for the sake of this exercise, I'm going to do x over 1. And so because I chose to go that direction, I need to mash it on the other side. X over 1, so I must put 555.5 over 1.5. Now, if you said 1 over x, then you'd have to do 1.5 over this. Okay, so you have to be consistent with your directions. So it's going to be 1.5x equals 555.5. And we're going to divide. And our answer is here. It says about how far, so you're rounding a little bit. So we will say 370. And since we already know what this is, you could say about 0.3, but you might as well say 1/3 because we know that 0.3 repeated is that. So there's a nice exact answer. Okay, number 3. They tell us that these are similar. One's a larger version of the other. It's just shrunk or it's enlarged. So that means they're in proportion to each other. So solving for x, we can just go ahead and set up a proportion. So 6 compares to x the same way that 4 compares to x minus 5/3. Cross multiplying. 4x equals 6 times x minus 5/3. So I'm going to get 6x. And now I'm going to go ahead. You can use your calculator, use the fraction. I know 6 times 5 is 30. And then minus 3, divided by 3 is 10. And now I can go ahead and solve this out. Now, ideally, I don't really want to clear out the smaller one here because it leaves this side empty. So I'm going to get rid of the 6x by minusing it. That gives me a negative 2x equals negative 10. So again, notice I got rid of the bigger one, which left me a negative. Normally, we don't want that, but it's on this side. If we cleared out this side with a 0, we'd end up having to move the x over there, and it would be negative when we did that anyway. So this saves us a step. We didn't clear out the entire side. Now I divide by a negative 2, and my final answer here is 5. X equals 5. Part B now, what's the ratio of similitude from the larger to the smaller? So comparing sides, but we know x is 5, and you could go find out what this is if you wanted to, but this is already a nice ratio, and it's going to be equivalent to this one, so you might as well use the easy numbers. The ratio from the larger to the smaller is 6 to 5. Okay, number 4 I'm going to do over here. Got a triangle, sides of 8, 15, 17. Find the perimeter of a similar triangle whose smallest side is 12. So I'm going to go ahead and make a triangle. We're going to pretend that these are similar. It's the same triangle, just a different version. So this is 12. So I'm going to set up some proportions to solve for my missing sides. I'll call them x and y. And then once I have x and y, I can find the perimeter by adding them all up. So when I go ahead and set this up, I have to use the 8 over 12. It's the only match that I have. If you did 15 over x equals 17 over y, you don't have enough information to solve. So I need the 8 over 12. And now you can go for either one. I'll start with x. Since I went from 8 to 12, I have to go from 15 to x. So cross multiplying. 8x equals 15 times 12. So 180 divided by 8. It's 22.5. So this is 22.5. And then separately for y now, I can go ahead and use the 15 over 22.5 if I want to, or I can go back and use the 8 over 12. But I must include the 17 over y. So I'm just going to go ahead and start with that. And now when I choose this, either one is fine. 8 over 12 will work. 15 over 22.5 will work exactly the same. I'll just grab 8 over 12 because it just looks easier. So 8y equals 12 times 17. It's 204, and we divide that by 8. And we get 25.5. And so to answer the question, find the perimeter of a similar triangle. So find the perimeter, adding up all the sides. So it's 12 plus 22.5 plus 25.5, which comes out to 60. All right, and number 5. We have a triangle with side lengths of 6, 8, and 10. Second triangle has side lengths of 8, 10, and 12. Are they similar? So to be similar, the matching sides need to have equivalent ratios. So these matching sides are 6 to 8. And some people would ask, well, how do you know that those match up? But if you look, 6 is the smallest of the 3. So if these were similar, the smallest of these 3 is 8. So these need to be the same. They need to equal all of these. 8 over 10. And the biggest side here matches the biggest side here, 10 over 12. So the question is, are these equal? So if you do 6 divided by 8, that's 0.75. If you do 8 divided by 10, it's 0.8. So I already can stop. And if I do 10 divided by 12, it's 0.83 repeated. So these are not equal. So the answer is no. They said explain. So the ratios of corresponding sides are not equal or are different. They would all have to be equal for these to be similar.